Okay, on page 708 today, let's take a look at example number 3 up there on the top of the page. And you're referring to a circle graph. Find each measure. So we're going to say that when finding arc measures, in a circle graph, multiply the percentage of each piece by 360 to find each arc measure. All right, so when we're finding arc measures in a circle graph, multiply the percentage of each piece by 360 to find each arc measure. So what that means is if you got a circle graph, and we've got different pieces. Some people call it a pie chart. And call it whatever you need to call it. We'll label these points here A, B, C, and D. Now, in these graphs, you're given the size of each piece of the graph in a percentage. So this looks like it's about not quite 50%. We're going to go with 40% of the graph. And then this might be 25%. And then let's go 35, and let's say this is 30%. So 70, 20, 90, so this is 5%. Whatever the graph is, whatever the percentages are, you're given the circle graph. It's got different pieces in it. Each piece typically represents something. It's labeled in the graph. And if you're asked to find the measure of arc AB, all right, you're looking for the measure of arc AB. It's right here. Well, the arc from A to B represents 25% of this circle graph. So what we do, the measure of arc AB is going to be equal to 25% or 0.25 times 360 degrees. There's 360 degrees in a circle, but we're looking for 25% of 360 degrees. All right, and 25% of 360, that's 90 degrees. If you need the measure of arc BC, arc BC represents 5% of the circle. So arc BC is going to be 0.05 times 360. And that's 18. Now we're in degrees. Okay? We're in degrees. If we need the measure of arc CD, arc CD represents 30% I'm sorry, I put degrees after these. This should be percent inside this circle here. This is percentage, percent. All right, so arc CD represents 30% of 360 degrees. So we take 0.30 times 360. And it's 108 degrees. If you needed the measure of arc ADC, now we're talking about a major arc, right? Starting at A, coming down here, going through D, and then ending at C. Well, if that's the case, then we have to use a combination of those two percentages. Because now arc ADC represents 40 plus 30% of 360. So that's 0.70 times 360. And 0.70 times 360 is equal to 252. And that's in degrees. All right. Any questions on finding an arc measure when you're working with a circle graph or a pie chart? All right, then look at arc length. All right, now just make sure that you're clear on arc measure and arc length. Okay, arc measures are in degrees, and arc length, this is super important that you don't get this confused. Arc length is measured in the same units as the radius, diameter, or circumference. All right, so what we're going to say here, arc length. We're going to use lowercase l is equal to central angle over 360 times 2 times pi times the radius. So this is much simpler than it looks. So let's get a circle on your paper. And we're going to put a central angle in here. This central angle is the x that's in the formula. This arc length, this red portion, is what we're finding by using this formula. That's going to be our L, our lowercase l. And obviously, 2 times pi times r, the r stands for radius, so this is our radius. So you could be given this in picture form and asked to find the arc, or you can be given it in sentence form and asked to find the arc. So we're going to do it in picture form first. So let's look at example 5a. Example 5a, we've got a circle. It's got a central angle in it. The central angle is 75 degrees. The radius is 4, and it's in inches. And you need to find the length of arc YZ. And you're asked to find it to the nearest hundredth. So again, the length of arc YZ, here's the arc. We're just going to plug it into the formula. The length of arc YZ, we can say that YZ is equal to the central angle that corresponds to the arc. The central angle is 75 over 360 times 2 times pi times the radius. And the radius here is given, and it is 4. So from here, you can go straight across with your calculator. You're rounding to the nearest hundredth. You got your calculator set to second fix 2. All right, so take 75 divided by 360, hit equals, and then times 2 times pi button times 4, and hit equals. And I got 5.24. And since our radius was in inches, then the arc length is in inches. Questions? Now, hopefully you recognize this formula, the 2 times pi times radius. That's circumference formula, right? That's the circumference formula. You could also use pi times diameter right here, can't you? Because pi times diameter gives you the circumference as well. So if you're given this picture, let's say we got this circle, you're given this. And this unit is 10 centimeters. And a central angle of 130. And here's your arc YZ. We're trying to find this arc length, Y to Z. But we're not given the radius anymore, we're given the diameter. So YZ is equal to 130 over 360 times, you can use 2 times pi times radius if you want, but don't use 10 for the radius because the radius isn't 10, is it? The radius is 5. So I'm just going to use pi times diameter. This portion of the formula is circumference. There's 2 formulas for circumference. If you're given the radius, use the radius formula. If you're given the diameter, use the diameter formula. It's just a couple less buttons you got to type. So 130 divided by 360 equal sign times pi button times 10 equal sign. And you should get 11.34. Our diameters in centimeters, so we are in centimeters. Anybody have any questions on finding arc length? All right, and then just before I give you your practice, there were some questions asked yesterday. And right now you're better off putting your pencil down and just watching for maybe a minute. Throughout the entire year, you've been given pictures like this. And if this portion of this linear pair was, say, 80 degrees, then what was the measure of the left side? 100, because they're a linear pair. Now look, this drawing may not turn out very good, but if I just put a circle around this, and this is a diameter, isn't that still the same? Because there was a picture like this in your assignment yesterday, and some students were coming to me asking how to find certain measures. If we have this, and we've got a diameter going through it, and here, and this is 110, what's that angle? It's 70. It's still a linear pair, whether it's surrounded by a circle or not, okay? So continue to use all your rules about intersecting lines or intersecting segments. If these two segments intersect, and this angle is 60 degrees, what's the angle right below it? 60 degrees, because they're vertical angles, right? And because they're vertical angles, in this case, you have a linear pair. This is 120, and this is 120. Now, if the same thing happens inside of a circle, everything is still true that you've been working with all year, if you get this picture. And this over here is 50 degrees. Then this angle, its vertical angle is 50 degrees. All right, this would be 130, and this would be 130. So your rules related to linear pairs and vertical angles are all still true, whether the segments or lines are increasing without a circle, intersecting without a circle, or within a circle. All right, because in just a little bit of time, we're going to be taking this same picture and extending all these lines. And now we're not dealing with chords, we're dealing with secants. All right? But everything remains true inside the circle. Vertical angles are congruent. Vertical angles are congruent. And a linear pair of angles, some 180. Okay? So keep that in mind when you're looking at these diagrams. All right, so your practice for today. Page 710. Six, 10, 11. And then over on the next page, you got 24. And then 36 to 41. I'm going to remind you to do your assignments in a timely manner. I'm not leaving the homeworks open for the entire week. So be sure you check the due date on the electronic assignment, because the whole idea is that you do the electronic assignment the day that it's assigned, you do the practice problems the day that they're assigned, and you do the electronic portion for homework. Okay? So we're not going to be waiting till Friday to do problems that should have been done on Monday, Tuesday, and Wednesday any longer.